the addition with the carry. And I purposely skipped part A because I just saw an error in the textbook. I hate to see these. There's a couple here and there, but check out this one. What do you see here is the error in the number 5. Yeah, I screwed up right here. So this should be 0, 1, 0, 1. And then the 2 is all right, and then the sum is okay. And then the 8 plus 3, everything's okay. So anyway, check all these out. Do these off on your own just to get extra practice before you do the homework problems. Okay, now for subtraction, 4 possible combinations in the least significant column. You could have 0 minus 0. That would be 0, no borrow. 0 minus 1. To do this, you have to borrow first. And then you would end up, when you borrow, this column would end up being a 2. And that's why you end up with 1 for the remainder. 1 minus 0 gives you a remainder of 1. You didn't have to borrow. 1 minus 1 is 0. You didn't have to borrow. So here's a general form in the least significant column. The A0 minus the B0 gives you the remainder and a possible borrow. And when you look at the truth table for this, this helps illustrate the operation also. 0 minus 0, like I said. And the difficult one is right here. When you have 0 minus 1, you have to borrow. So, and when you borrow, when you look at it down in this area, if you have 0 minus 1, when you borrow from the left, that becomes a 2. And you borrow from this side, that gives you a 2 in the LS column. So really, you're saying 2 minus 1 gives you a 1 for the remainder. So that's how this truth table column works out. 0 minus 1, you had to borrow, but when you borrow, you get a 2, and then the 2 minus the 1 gives you that 1 for the remainder. Now, things get a little more complicated in the more significant column. So here's the LS column. If there was a borrow, that becomes a borrow in the next column. So now you have 3 things to look at, and that's why the truth table actually has these 3 different columns, the A1, B1, and the possible borrow in. And again, unless you get a remainder 1 and a possible borrow out also. So all zeros, that's easy. But in this column, you're saying 0 minus 0, but keep in mind that we had a borrow in there. And so I write this note. The borrow out was required because the B in, this B in right here, needs to borrow from A1, but A1 was a 0, so we had to have a borrow out in the next column. So this turns out to be a borrow out is required, and we'll end up with a remainder 1. So this is probably one of the most difficult pieces on this function table. So what I have a little bit later is an illustration of the subtraction of 4 minus 1 down below. And so down here near the bottom, here's a 4 minus 1. And here's what it looks like in binary, 0, 1, 0, 0, 0, 0, 1, and so on. So again, in this first column, we had to borrow. So when you borrow from here, that becomes a borrow in. But there's nothing to borrow from. So this column had to borrow from the 4, which was over here. So this 1 becomes a 0 because you're borrowing from it. That brings over a 2. But the 2 was borrowed from, so that's really going to be a 1 left. And that 2 that was borrowed from becomes a 2 in this column. So now when you do the subtraction, it's 2 minus 1 is a 1. In this column, you have 1 left. 1 minus 0 is a 1. In this column, you have none left. 0 minus 0 is a 0. And when you look at the final answer, 4 minus 1 is supposed to be 3? Sure is. When you do it in binary, 4 minus 1 gives you 3. Check, it worked out. Now, in example 7.2, I'm going to perform several subtractions. So let's take the number 27 minus 10. We know that should be 17. So 27 is made up of a 16, an 8, a 2, and a 1. And then 10 is made up of the 8 and the 2. Now we subtract. 1 minus 0 is a 1. 1 minus 1 is a 0. 0 minus 0. 1 minus 1 is a 0. 1 minus 0 is a 1. So that was real simple. So you get the 16-bit and 1, 17. It does check out. And I progressively get a little bit more difficult as we go along. Here's the 9 minus the 4. So you got 1 minus 0. That's easy. 0 minus 0. This 0 right here had to borrow from its left. So this becomes a 2. 2 minus 1 is a 1. So this does check out to a 5. So I'll leave it up to you to go down through the next few examples and see if you can come up with the same answers that I have for parts C, D, and E. And first of all, you do it out in decimal. Then you write out what it should be in binary and see if you come up with the exact same answers. The good things about this is you can always check yourself because you know how to do it in decimal. And when you come up with an answer, it better check out. Okay, so that concludes this part of section 7-1. So we've covered the addition and subtraction. And next, I'll end this podcast. Well, the next one will conclude with the multiplication and division. Okay, so that's it for now. Hi, this is Professor Kleitz. Continuing in section 7-1, we want to cover multiplication. It's just like decimal multiplication, except you deal only with ones and zeros. So let's take a look at the multiplication of the number 13 times 11. First of all, convert it over to binary. That's the 8 with the 4 and the 1, and the 11 is the 8 with the 2 and the 1. And you have to be careful lining up your columns. So you multiply 1 times the multiplicand, and basically just write the number down underneath. And then you shift over by 1, and then we take the 1 times the multiplicand, shift it over, and then the 0 times multiplicand, and make sure you line these up carefully, and then we add them all up. 1 plus 0 plus 0 plus 0 is a 1. 0 plus 1, da-da-da-da-da-da-da. So you work these out. No, actually, don't mean this goes so fast. This one, we have a 1 plus 1 plus 1. Okay? Now, 1 plus 1 would be 0 with a carry. You throw 1 more in there, and it's a 1 with a carry. And then you go into this column, and remember the carry plus a 0 plus 1 plus 0 plus 0 is a 0 with another carry. So there's going to be a whole series of carries going on that you have to keep track of. So finally, by the time we're done, we end up with the product at the bottom, and if you list that out as an 8-bit number, you'll end up with a 1, 0, 0, 0, 1, 1, 1, 1, and you check that out, it's 143, which is exactly what we got when we did it the longhand method. So to help you follow the procedure, I listed out 6 steps that we just took to get the final product of 143. So you can read through these just to supplement your knowledge on the solution to that figure 7-3. So now in example 7-3, we're going to perform several multiplications, 5 times 3, 45 times 3, and so on. And again, try it first of all in decimal, and then you can write it out in binary and add up the sum and so on. And we'll see later on in the chapter that multiplication is done by a series of additions and shifting. So you shift the bits over to the left each time you have a new column formed. And shifting we'll actually cover in chapter 13. And by the way, take a look at this common misconception, though. Over the years of teaching, I found that most errors in binary multiplication occur when the students are careless in the vertical alignment of the addition columns. Now, we don't have too many columns here, but when you look at the more advanced problems, like part C and D, when we have a lot more columns, you can see that if you aren't careful in the alignment, you shift these bits one way or the other incorrectly, you definitely get the wrong answer. So check these out on your own. So make sure you try these on your own. 15 times 15 is a good one to do. Write down the binary values and do this off on your own, and then check to make sure you get that same answer, 225. So another team discussion out here is develop a method to determine the value to carry when